Hey everyone, in this video we're going to start talking about equations, and we're going to start small with some one-step equations. So first what I want to talk about is what is an equation and why do we even care? I think the best way to have that conversation is through a couple real life examples here. So say you're running a business, like this business in Evanston called Metal Sports. So Metal Sports spent $8,000 last month, let's say. Okay, that's the total. And break that down, they spent $2,000 on materials and X dollars on marketing. So materials and marketing. Okay, now first and foremost, what is a variable? X just represents some unknown number. That's supposed to be an N. Okay, so we don't know how much money that they spent on marketing, so we call X, which just is a placeholder, say we don't know. Okay, and the goal is to figure out how much did they spend on marketing. But first I'm going to translate this statement here into an equation, because really all an equation is a mathematical sentence. Okay, so in total they spent $8,000. It was $2,000 for materials and an unknown amount in marketing. So before I translate that into an equation, I just want to translate that into an actual sentence. Okay, so we're talking about how much money they spent. So in total, we know that total, they spent $8,000, but the total is made up of materials and marketing. So if you take the amount they spent on materials and you add the amount they spent on marketing, you're going to get the total that they spent. Okay. So if you just translate in English, that makes sense, right? Materials and marketing costs would be the total. And now we can substitute in the values that we know. So we know the total was $8,000. We know the marketing cost was $2,000, but we don't know what the marketing cost was. And that's where we call it X. So I just translated the above into an equation. An equation is just a mathematical sentence. Why do we have an equation? It's so we can solve for something that's unknown. So in this case, we're trying to figure out what they spend on marketing. An equation will help us do that with a step-by-step process instead of having to guess and check. Now, when it's one step, it's not actually that bad to guess and check, because you can really look at this and say, okay, 2,000 plus what amount of money will give me $8,000 total. So the nice thing about one step one is you should be able to think these through. What would you have to add to 2,000 to get 8,000? And I hope in your head you're saying X would have to be $6,000, because 6,000 plus another 2,000 would give you 8,000 total. Okay, again, this X just represents that unknown value. But as the equations get more complicated, this isn't always as easy. Okay, and that's where I want to talk about the steps to solving a one-step equation. Just keep in mind that this equation here means the exact same thing as X plus 2,000 equals 8,000. Doesn't matter the order, because this still says marketing plus materials is 8,000 total. And remember, 2,000 plus X is the same as X plus 2,000, because 2 plus 3 is the same as 3 plus 2. Okay, so order doesn't matter. This is the exact same equation. You can always rearrange if that makes you feel better. Okay, so if you don't just think this through and say, okay, 6,000 plus 2,000, 8,000, this is what you would do to solve. So every equation has two sides, and your goal is to get the variable on one side and numbers on the other. Okay, so at the end of this, I'd want the variable on one side and any numbers on the other side of the equal sign. Okay, which is why I drew that line there. So right now we have X and plus 200 on this side, but we only want the X on this side. So we have to get rid of the plus 200. The way you get rid of something in an equation is you undo it with an inverse operation. So how can you undo or cancel out 2,000? Well, you can subtract 2,000. Okay, why does that work? Well, 2,000 minus 2,000 is 0. So that would really be X plus 0. X plus 0 is really just X by itself. Okay, so that's why that'll work here. But in an equation, you need to keep it balanced, meaning whatever you do to one side, you have to do the other side as well. So if you subtract 2,000 here, you need to subtract 2,000 here. Okay, so again, you have plus 2,000, you subtract 2,000, that's 0, so you're just left with X. Okay, that was our goal, to get X on one side and numbers on the other, which you can see is going to happen here because we have 8,000 minus 2,000. Well, I have $8,000. I take away 2,000. Now I have $6,000. Okay, so no matter how you solve it, if you think it through or you do the steps, okay, you should get the same answer. But what this video is going to continue to go through is how to do those steps in a variety of scenarios. I'm going to leave number 2 for you to think about and try. Okay, can you write an equation and what is the solution? Okay, now I want to talk about the steps of solving an equation so you have a process here. And these steps might be easier for one step and they might be a little bit more difficult for more complicated equations, but these steps will be the same for every equation that we do solve. Okay, so first and foremost, you always want to make sure each side of the equal side is simplified. So you want to simplify both sides of the equal sign. Okay, now in the problem I gave you above, there was nothing you could really simplify on either side, right? You can't do anything with 8,000. That's as simple as it gets. There's nothing to add, subtract, distribute, etc. Same thing here. Those aren't like terms, so you couldn't combine them. There was nothing to simplify. So this step will usually apply more to a multi-step equation, not necessarily a one-step equation. So we'll get to that in the future. Some multi-step equations. I'm abbreviating equations right there if that's equations. Okay, once you know that each side is as simple as possible, I want you to remember your end goal. Okay, your end goal is to get your variable on one side and your number on the other. Let's write that down. Make sure you're writing this down as well. Actually, I'm going to rewrite this. I'm going to isolate the variable. And then in parentheses, I'm going to explain what that means. Okay, so you're going to get variable on one side of the equal sign and numbers on the other. On the other side of the equal sign. Abbreviating that a little bit there. Okay? And I guess this is step 3, but it's really more of a two-part 2. But in order to isolate the variable, you're going to use inverse operations to do so. Okay, so inverse operations are operations that undo each other. Such as addition and subtraction, or multiplication and division. Okay, those are inverse operations because they undo each other, right? Like I did up here. So if I had plus 2,000, I subtracted 2,000 to get the variable by itself. So these two steps are really connected. Last but not least, I always say you should get 100% on a solving assessment, quiz or test, because you should always check your solution. You can always see if it makes sense. For example, in the above problem, okay, if I got x is 6,000, well, let's just evaluate this and make sure it makes sense. So if x is 6,000, that means 6,000 plus 2,000 is 8,000. If that's true, you got it right. If that's not true, you did something wrong in your solving steps. So that's nice that you can always check your solution. So we're going to employ these steps with a couple problems here, and that'll be the end of the video. Okay, in number 1, we have 4w equals negative 24. So first thing I actually want to do is I want to think this through, and then we'll go through the solving steps. So remember 4w really means 4 times w. We just don't use that x anymore because that could get confusing with the variable x. So when you write them together, assume that that's multiplication here. And you just write two things next to each other. So it says 4 times w, which really means 4 times some unknown number is negative 24. Because remember, a variable is just an unknown number. So in your head, I want you to be thinking like 4 times what number is 24? And then maybe 4 times what number is negative 24? And I hope you have an answer in your head right now, but if you don't, let's go through those solving steps. Okay, so we can't simplify on either side. That's for multi-step equations because, well, there's nothing to do here or here. So then we're going to isolate the variable because at the end of this, I want w by itself and the numbers over here. Okay, so in order to have w be by itself, I need to get rid of this 4. So it's 4 times w. What's the inverse of multiplication? That would be division. And why does that work? Well, 4 divided by 4 is 1, and 1w is just w, so it'd be by itself. All right, 4 divided by 4 here. That's division. Whatever you do to one side of an equation, you have to do the other side of the equation. Okay, so 4 divided by 4 is 1, so that's 1w is by itself. And then you're going to do negative 24 divided by 4. So first of all, it should be a negative, because a negative divided by positive is negative. 24 divided by 4 is 6. You don't really need the 1 here, because 1w is the same as w. So at the end of this, I get w equals negative 6, which I can check and say, is 4 times negative 6 negative 24? Yes, it is. Okay, just thinking of something I should add to this list is, when you're using those inverse operations to undo each other, make sure you do the same thing on both sides. So I divided by that negative 4 on both sides. Or that positive 4, sorry. Again, you should be writing this down. Okay, so I know in this particular scenario, we weren't solving in a context, but this could easily represent a context where, we're solving for some unknown thing for our business. So it could be like 4 people have $6 in debt. So $6 in debt 4 times would be a total of $24 in debt, right? An equation just helps us solve for an unknown in any given problem. Cool. I'm going to leave number 2 for you to try on your own. If you have any questions, please let me know. But we're going to do number 3 together because I know people don't like fractions. This is hard to write on, so I'm just going to recopy this real quick. Okay, remember, I've said this before, but a fraction is just division. So what this problem really says is c divided by 3 equals 20. Or you have some unknown number that we called c, and when you divide that number by 3, the result is 20. Can you think that through in your head? What divided by 3 is 20? If not, we'll go through the steps. So we don't do step number 1 because there's nothing to clean up in a 1 step. So we're just going to get the variable c by itself and get the numbers on the other side by using inverse operations. So what's the inverse operation of division? How do we undo divide by 3? Well, the inverse of division is multiplication, so we're going to multiply that fraction by 3. Or you can look at that as 3 over 1, so that's a little bit easier to see with fraction scales that you can cross cancel. Because you have multiply by 3 and divide by 3, that would give you 1, so they cancel out. Whatever you do to one side though, so we multiplied this side at the end of the day, remember by 3, you have to do the other side as well. What's 20 times 3 would be 60, which as always we're going to check and see if that makes sense. So the unknown is now 60 instead of c. Is 60 divided by 3 20? Yes it is, so we know we got that correct. Okay, so that's 1-step equations. A couple key points is, using inverse operations to get the variable on one side and the numbers on the other. And also just that an equation is a mathematical sentence that represents some scenario that helps people in all sorts of fields figure out unknown numbers. Okay, and as we get more complex in our equations, we'll see why they're more helpful. That's all I have for today. If you have any questions, let me know, and have a good rest of your day.